Hi guys, welcome to our MPLAB XC8 tutorials for absolute beginner series. This is tutorial 62, part 1 of tutorials covering the USB communication. We're gonna start with a quick introduction, then we're gonna discuss some few USB device classes. We're gonna start with the USB communication device or CDC, then the USB human interface device or HID, and lastly we're gonna discuss the USB mass storage device. We're gonna learn how easy you can integrate a USB to your product using MPLAB Code Configurator or Microchip Libraries for applications. USB is an asynchronous serial communication protocol and it stands for Universal Serial Bus. Before USB, there were too many different port types, like the serial port that once used to be very popular on personal computers and other hardware compliant to the RS-232 standard, like modems or similar communication devices. This port is also known as DB9 connector or COM port. The parallel port, mostly associated with the printer port, found mostly on personal computers in the past, but virtually not existent today. The PS2 port, once popular also in the past on keyboard and mice. The SCSI connector, just to mention a few. The USB was designed to replace those myriad of connectors found on personal computers in the 1990s. The primary motivation was to allow peripherals to be automatically configured when they are plugged into a PC, often referred to as plug and play. With USB, you can simply plug a new USB peripheral and the host will immediately recognize it, like plugging a keyboard into your PC while it's already running. There is no problem. In the past, with the PS2 keyboard, you had to reboot the PC for it to be recognized. Some of the old connectors, like the parallel port, had so many connectors, it was taking a significant port space on the motherboard. This can become really expensive if you want to implement multiple peripherals. Shortly after being introduced, USB port quickly replaced the legacy connectors on most PCs. Today, USB has grown beyond PCs to become the common interface for many embedded industrial and consumer products like in cameras, headphones, printers, and many more. So let us look at a typical USB system. USB is an asynchronous serial protocol, which means there is no dedicated clock line. A USB system is unidirectional communication consisting of a single USB host and multiple peripheral USB devices connected to a tiered star topology. If more than one device is present, we can include hubs in the tiers to expand the number of USB ports. USB hubs can extend a USB network to a maximum of 127 ports. A USB is an addressable bus line with up to 7-bit address code. This can support up to 127 devices. The address 0 is not a valid address. There is some benefit with this tiered star topology. Firstly, the power to each device can be monitored or even suspended if an overcurrent condition occurs without disturbing other devices on the network. We can also have low speed and high speed USB devices on the same network with no problem. All components of a USB system connect to each other using one of the USB specified cables and connectors. There are different types of USB connectors grouped into host and device connectors. The A connector faces the host like a computer, and the B connector faces the device like a printer or an Arduino board, for example. to reduce the size of the connectors. They are USB mini and USB micro connectors. The USB Type-C packs 24 pins into the USB connector. Unlike the previous versions, this version is reversible, meaning the USB connector can be inserted either way. There is basically no wrong way you can plug a USB Type-C cable. This allows also for current above 500 mA for your device. But depending upon the mode of operation, all of the signals may not be needed. This new Type-C is becoming the standard for many new devices like laptops and phones. The USB Implementers Forum, a non-profit corporation founded by the group of companies that develop the USB specifications, are responsible for updating and approving the USB specifications, including the protocols, speeds, connectors, and power distributions used by USB systems. In terms of speed, USB has 5 supported speeds, each with a slightly different protocol and frame format. The USB 1.0 has low speed with data transfer rate of 1.5 megabit per second and the full speed at 12 megabit per second. The USB 2.0 allows high speed of 480 megabit per second. Now with USB 3.0, you can reach 5 gigabit per second, and with Super Speed Plus with USB 3.1, you can go up to a whopping 10 gigabit per second. When connecting devices with different USB versions, the data transfer rate will be limited by the slowest of the connected devices. For example, if you connect a USB 2.0 device to a USB 1.0 device, the data transfer will occur at 12 megabit per second, even though the USB 2.0 device is capable of transferring data at 480 megabit per second. The USB host can also supply power to the USB devices, eliminating the need of the device to have its own power supply. The USB specifications also provide for battery charging specifications to allow a USB host to charge the battery of the device. In USB 1 and 2 mode, the host can supply a maximum of 500 mA of current at 5 volt, while in 3.0 or 3.1 it can supply up to 900 mA. Type-C systems are capable of supplying more power with up to 3 amp when using the new Type-C cable. USB has got many advantages, that's why it's very popular nowadays. Firstly, USB is hot pluggable. You can plug your USB device to your computer and it will be detected by your operating system immediately. No need to reboot your computer. USB is plug and play. Again, once you plug your USB device, the operating system will recognize it and load the appropriate driver for it if available. No need to configure it manually. USB support many devices up to 127. The distance can go up to 3 or even 5 meters in length. USB allows for low-cost devices, and for most of the devices consuming from about 100 mA to 500 mA, you won't even need an additional power supply for them. They can be powered from the USB host. USB also has a robust error detection. A malfunctioning USB device can be electrically removed from the bus without affecting others. The host can also instruct a device to enter a suspend state, which reduces the maximum power consumption to 500 microamp. The USB is also a high-speed bus with low speed of 1.5 megabit per second and currently up to 10 gigabit per second with USB 3.1 Super Speed Plus. Now, if you look at the disadvantages, USB is a very complex protocol to implement compared to USART, SPI, or I2C protocols, where you could simply add the peripheral interface to your project with some few library codes or even by accessing the registers directly by reading the datasheet. With USB, it's really different. You need to write your code off the USB framework, otherwise you'll really have a huge mountain to climb. USB is an order of magnitude more complicated than the other peripherals. It must be constantly serviced to maintain a connection to the host. USB is not also a free protocol. If you implement your own device, fees may apply. Every USB device product line is required to have a unique combination of VID and PID number that you need to buy. Let us look at USB device classes. The functionality of USB devices is defined by class code. Device classes enable the same device driver to be used for several devices having similar functionalities. This allows the USB host to load suitable software driver for each connected device. This provides for adaptability and device independence of the host to support new devices from different manufacturers. The table below shows the currently defined set of base class values, what the generic usage is, and where that base class can be used. The class 1 is used for USB audio devices like sound card, speaker, or microphone. For communication class or CDC, the PIC microcontroller looks like a modem, Ethernet adapter, or terminal connected to a COM port. The HID is used for devices like keyboard, mouse, or joystick. We've got also the physical, the image, the printer for printers, the mass storage for devices like memory card, external hard drive, or digital cameras. We've got the hub, we've got the CDC data, the smart card, the personal health care for devices like thermometer, blood pressure, or glucose meter. We've got the audio video devices, we've got diagnostic devices, wireless devices, and we've got also the vendor specific, which is a custom class for vendors to use as they please. You can learn more about these device classes from this USB Implementer Forum website. As we have said earlier on, the USB protocol is very complex. In this tutorial, we're not going to discuss in detail this protocol. There are many resources online and books covering this topic in detail. Here we're going to just discuss the basics and how to use Microchip supplied middleware such as Microchip Libraries for applications or MPLAB Code Configurator to develop a USB application. Microchip supplies a full portfolio of USB enabling products including devices, hubs, transceivers, and power controller. Some PIC16F1 and PIC18F series can be used as USB devices. USB devices are peripherals that can be attached to a USB host like a PC. Typical devices include products such as keyboard, mice, or medical devices. Some PIC24, DSPIC, PIC32MM, PIC32MX, and PIC32MZ series can be used as both device or host. A host controls all communication within the system. The host sends communication requests and devices respond. Devices do not initiate data transfer event. In the past, nodes in USB networks operated in either device or host mode. They couldn't change roles. USB on the go or OTG and USB v3 and above provide the ability for a node to change roles from device to host and vice versa. For example, you might need to connect a USB flash drive to your phone. With an OTG cable, your phone will act as a host, while it can also act as a device when it's connected to a PC. Microchip Libraries for Applications is a collection of Microchip firmware libraries, drivers, demo project, documentation, and utilities for different types of applications including USB, graphic displays, memory card, TCP/IP, smartphone, and many more. If you're using a newer PIC16 or PIC18F, it's advisable to use MPLAB Code Configurator, as it's going to simplify the code generation. Everything will be done graphically. If you go to current download, the USB Framework Lite, currently it supports only the CDC and the vendor class. These are some of the requirements to use this library. And these are the currently supported devices. As you can see, it does not support the old devices like the popular PIC18F4550 is not supported, but the newer version, the 45K50 is supported. And these are the 16-bit supported devices and the 32-bit supported devices. Let us go back to Microchip Library for Applications. The firmware library support these applications like the USB, the graphics, and so on. The current version is 2.18. Here it says it does not support the PIC18F, but it currently supports it. Let us open the release note. For some reason, they haven't updated this web page. Let us open the release note. It's going to give us more details. Great. As you can see, the current version 2.18, it supports the PIC16F series and PIC18F series, and 16-bit, the PIC24 and DSPIC, and also support the PIC32mm in the 32-bit architecture. So what you have to do is just to download the current libraries depending on your operating system. I'm using Windows, so you can just click on download. Then it's gonna start downloading and you can install it. I usually prefer to install in the default location, which is gonna be in C. It's gonna create Microchip folder in your C directory, MLA. The app folder contains the application examples. So if you click on apps, in this example we are using USB. The device folder, here we're gonna find the example for USB device, the host for USB host, and the factory demo. This folder contains the pre-programmed demo.hex that are ready to run with Microchip development board. In this case, we've got device. The simplest way to get started is to use one of these examples, then modify them to suit your need. You can't just copy a project folder from this directory. It won't work because it has dependencies with other files in other folders, and sorting those paths will really be a nightmare. The best option is to package your project. This will create a zip file with all the required files and folder to run your project from a different location. Always do this. Don't modify the original example project, as you might need them later. Okay, let us see how you can package an example. Let us open one of these examples. Open the apps folder, USB, device. Let us open this CDC basic. These are some utilities like the device drivers. Open the firmware folder. Depending on the PIC that you are using, you can choose one of these examples. I'm using the PIC18F45. Okay, for PIC18F45K50, you can use this PICDEM-FS USB K50, or for the PIC18F4550, you can open this example. The details of these examples are described in the help file. So if you download the help files, it's going to explain in details about all this demo project. So open this PICDEM-FS USB project. Properties. You can see this demo uses the PIC18F4550. Build the project. Great. As you can see, this demo project are ready to be used. All you need to do is to use these examples as the base for your project and modify them to suit your need. To copy this project to a different folder so that you don't have to modify the original files, as you've said, you can just right click, select package. This is going to create a zip file. It was packaged in this folder. You can just click on this link. It's going to open the folder, and you can just cut and paste your project to a different location. These are the different examples that you can use to get started. We've got CDC examples, HID, mass storage device, vendor basic, audio microphone. If you're using Microchip development board, you can get examples supporting different development board in this folder. The framework folder. contain drivers and various middleware libraries. The doc folder contains documentation. So in our example, you can open the USB help file, then you're gonna get all the information that you need, how to use the different functions and macros for different USB communication classes. The utility folder contains common utilities that are used by multiple application examples, libraries, got some USB drivers for different operating systems. And that's all guys for this tutorial. In the next tutorial, we're gonna start with the USB communication device class. We're gonna learn how we can use this Microchip library for applications or MPLAB Code Configurator to add a USB to our application. Thank you guys for watching this tutorial. Don't forget to subscribe to this YouTube channel to receive more tutorials in the future. If you've got a question, don't hesitate to leave a comment, and I'll see you guys in the next tutorial. Thank you.